And in relation to the products and solutions that you have, very extensive, very well known, big heritage.
Yeah.
What are you showcasing today?
So at the show, we've got a few of our portfolios. So we've got X-ray CT technology. So this is all about measuring the inside of components, not just say the surface of a component. We've got microscopy, where your traditional microscope, from a physics lab, maybe at school, just making small stuff big. We go so much further than that, where we're using digital microscopes to automate processes with smart software solutions behind them. And they can connect in with things like our scanning electron microscopes. So maybe we find a defect with a light microscope, and then the software can automatically go in, interrogate that in much more detail and do elemental analysis within the scanning electron microscopes. And finally, in terms of the hardware here today, we've got optical 3D scanning. So nice, automated, efficient ways of capturing typically complex and maybe free-form geometries for inspection and reverse engineering. So Metrotom is part of our X-ray and CT range. So X-ray is nothing new. We know this from when we go to a hospital after an injury, but it's becoming very well established now within industrial measurement. So obviously measurement of the externals of components for a long time has been commonplace, but now we're using CT and X-ray to really understand the internals as well. So that might mean just making sure, if, for example, I'll give you a good example, would be a medical implant. If you were having a knee or a hip replacement, you'd want to know that that metal part was sound and hadn't got any internal defects. And a machine such as this can check that for you.
And how does this differ with other things on the market? Like, what's the USP for this?
It's a good question, that is, because if you look at the spec sheet for some of these technologies, we've got a 3K detector, we've got a particular KV X-ray source, but the spec sheet describes some of the hardware elements, but ultimately everything you're doing is in the software world. What we're doing is we're capturing information, we're doing software processing, and it's really what comes out the end of that software which differentiates one system from another. So when we often go, let's say, into a competitive situation, on paper the spec sheet of two machines might be similar, but actually clarity of images and what the software's created is where you'll start to see the difference between systems, and that's even before you start analysing that information. Microscopy, most people just think that you're magnifying things, and absolutely with scanning electron microscopes, they allow you to go to greater levels of magnification. But the scanning part of it is where we're using the device on the side here to understand and do elemental analysis. So it's all well and good being able to see particles, but now we can take that all a step further and understand what materials they actually are. So I'll give you a quick example. We'll talk about technical cleanliness, and this could be taking an oil sample from a machine. It could be just swabbing a surface before the next process, or it could be something like a failed component, and we can look at that under a conventional microscope or a digital microscope to see something, but actually then when we do elemental analysis, we can see exactly what material these particles are. So that really helps people in their understanding to then work out maybe where that debris or that contamination has actually originated from in a particular machine. So here what we're doing is we're using a digital microscope. So just as the name suggests, we've got a computer involved, we're taking images, and we can process those images. So this means that with software tools we can start to automate things. So if we want to measure similar components more than once, we can just create a template and bring some automation into it, which means we can save people a lot of time with operators, simplify processes, but at the same time it's made what's often even more important is that we're bringing repeatability in that analysis, and this is all in software tools in the background of the system. So what we've got here is an additive manufacturing powder. A lot of the machines use let's say a metal powder, for example, but they may recycle a percentage of that. So you fill a powder bed, you make a component, and then you recycle the materials not used. So obviously when you're doing this, it's very important to check that the material is what you expect it to be, because otherwise your final component, which could again be something like a medical implant, could be you could be creating that from a subgrade material.
Yeah.
So the idea of collaborative robots is that they can be used collaboratively. So sometimes that would be on a production line, working next to an operator, and obviously you want to be doing that without the robot being in a cage or having a safety fence around.
Yeah.
So we're using collaborative robots so that we don't need a box around the system, and the robot is robot's positioning the sensor for us at predefined positions so that we can take a complete 3D scan of the component. As you see here, we've got this little kind of plastic part, lots and lots of features, but we can capture all of those very quickly because we've got a nice big field of view for scanning and very high resolution cameras on the system, so which means we get a complete scan very quickly, and we can then put that to good use for inspection and get a really thorough, quick to understand inspection report.
And what are some of the industries that are using this type of technology?
So certainly plastic parts, stamped sheet metal parts, cast parts, forged parts, metal additive parts, the airfoil industry, whether that's for aerospace or power generation, would all be big adopters of this style of technology. We, as Zeiss as a company, are kind of well known for the hardware, but actually today, within the industrial quality solutions division, the software is becoming the much bigger part of the story. So you know, why is that? Well, ultimately, software is what everyone interacts with. That's what really gives the user experience. But also, we're in a fortunate position in that, as you've just seen, we've got some really nice broad portfolio. But the power of those different types of technology really comes together when we've got a single software solution.
As part of the future for metrology innovation, we sort of see three key trends. We're looking at decarbonisation, globalisation, and digitisation. From a globalisation point of view, obviously we have some heightened geopolitical issues of late. We're looking at a lot more cross-border innovation and R&D, which is ultimately driving that, the sort of the collaboration across the world and increasing that productivity and that efficiencies.
So within our conversations around the conference, there's been quite a lot of discussion around efficiency within manufacturing, specifically linked to IoT technologies, connected technologies to really track like energy consumption, drive sustainability, things like that. Is that something that you're investing in? Are you looking at IoT, industrial IoT?
Absolutely. So as part of our decarbonisation strategy, we're looking at all about how can we start to support the green principles from a manufacturability and a manufacturability point of view. So absolutely, we're trying to create a sustainable model that can be implemented, be it NEV, be it electrification from an aerospace point of view, whatever that may be. We're looking at how can we support that.
I think like a big challenge that we've seen at the conference, like from interviewing people around the conference, is the skills gap, like the STEM skills gap. How do you think that the industry is going to combat that?
As part of our strategy going forward is we're trying to link into the catapult centres and universities across the UK and Ireland. So there's a number that we're already working with in Ireland now, and we're also looking to understand how can we develop that further in the UK.